Section 2.1 will be talking about frequency distributions and their graphs. So a frequency distribution is going to be a table, and it's going to show the intervals or classes. So when we say the word classes, we're referring to a interval, and it's going to show the classes of data entries with a count of the number of data entries that fall within each class. So this is going to help us see how spread out the data is. So two commonly used words for frequency distributions is going to be range and obviously frequency. So range, the range of a data set is going to be the difference between the maximum and the minimum entry. So that just means we are going to be finding the largest value and subtracting from it the minimum value. And the frequency, which we're going to denote with a little f, is going to be the number of data entries that fall within a certain class, which remember is an interval. So the steps for doing this are going to be these steps right here. We're going to decide on the number of classes or intervals. So this is usually going to be given to us. It's going to tell us how many intervals to chop up the data into. Then we're going to divide the range. So we're going to find the range and divide it by the number of classes. This is going to give us what we call the class width. It's going to be the size of each interval, the size of each class. Then we're going to find the lower and upper limits for each class, and they can't overlap. And then we're going to go in and make a tally for each data entry in the row for the appropriate class in the table, and count the tally marks to find each class frequency. And once we have that table filled in, that's going to be the frequency distribution. So let's see what we mean by that with an example here. So let's construct a frequency distribution with 7 classes. So 7 classes with the following data set. So we have all these numbers, all these data entries, whatever they happen to represent. So I kind of just put the steps from the previous page just to let us know what we're going to be doing. So you can see, well, I'll scroll to the next page in a minute. So first, for the number of classes. So the number of classes is just 7. That's just given to us. So we're going to have 7 different equally sized intervals based on that data. So the range of this data set, we have to find the smallest value and the largest value. So it looks like the largest value is 340 and the smallest value is 65. So that means the range is going to be max minus min. So 340 minus 65, which is going to give us a range of 275. The class width, and once again remember that this means this is the interval size for each class. This is going to be the range divided by the number of classes. So this is just going to ensure that each interval is equally sized. So the range is 275 and number of classes is 7. So when we get an answer for this, we end up getting about, I'm going to put squiggly equals for about 39.3. What we have to do here is we actually have to round this up. So typically if we were rounding to a whole number, we'd be rounding to 39, but we're going to round up here. So this is going to give us, let me just make a little note, that we're going to always round up. So this is going to give us a class width of 40. So round up to the nearest whole number, so 40. So obviously we're dealing with whole numbers here, so we go up to 40. Okay, so now we want the lower and upper limits of each class. So for the lower limit here, so we know we're going to have 7 different classes here. The lower limit of the first one is always going to be just the minimum value in the data set. So we're going to start with the minimum value, which was 65. So what I'm going to do before we go to the next upper limits, I'm going to do every lower limit. So to find the next lower limit for the next class, what we're going to do is we're going to add this class width to it. So it's going to be 65 plus the 40, which is 105. So that's going to be the lower bound or the lower limit for the next class. Then we're going to keep on adding 40 until we have 7 of them for the 7 classes. So then we have 145, another 40, 185, another 40, 225, 265, and 305. So we just kept on adding 40, which is our class width. The upper limits for each one of these classes, since they cannot overlap, it's not going to go 65 to 105 and then 105 to 145. It's going to go 65 to 1 less from the next lower limit. So the next lower limit was 105, so it's going to be 65 to 104. So I'll make a note here, it's 1 less than the next lower limit. Okay, so what we can do is we can keep on going 1 less than the lower limit and say the next one's going to be 144, and then the next one's going to be 184, and so on. Or we can just keep on adding 40. So keep on adding 40. 104 plus 40 is 144. 144 plus 40, 184. And then we get 224, 264, 304, and then plus another 40, 344. Okay, so all we're doing is we just added 40 on both sides here because that was the class width. So now we have all 7 of our classes. We have 65 to 104, 105 to 144, 145 to 184, and so on. So all we did here, the only thing that we did, was we chopped our data set up into 7 equal slices using the range, which helped us find the class width, so it allowed us to find all 7 classes of equal size. Okay, so let's actually create this frequency distribution now. So I'm just going to fill in all of those classes real quick on the left. So they're all filled in now on the left. These are the classes from what we just filled in. And now what we're going to do is we're going to go back up to the original data and see how many data entries fall within each one of these classes. So let's take a look at 65 to 104 first. So go back up to the data set. So what I'm going to do is cross off how many data entries up here fall between 65 and 104. So cutting through here we have 1, 2, 3, 4, 5, and I think I'm missing one somewhere, and 6. So we have 6 data entries that fall between that class. So what you could do here, I just have this second column tally in just to kind of help you do it. So say you went and tallied and you got 6. That means it has a frequency of 6 for that class. So that means that 6 data entries fall within this interval. So fall within this class. So we can go through and do it for all of the other ones. So we would go through and look at the data set for 105 to 144, and we would count how many data entries fall within that interval, and we would tally it up and get the frequency. I'm just going to fill it in real quick just to save time. And this is what we would get if we went through and counted it. So I recommend that you go through and double check this. So the frequencies for each class, we have a frequency of 6, 9, 6, 4, 2, 1, and 2. Okay, so just one other thing here. If we went through and added up all of those frequencies, so this would be sigma f. So I'm going to use some math notation here. So what this means is, this is the Greek letter sigma, capital sigma. And if you don't know, it represents a summation, which means adding. So what this means is we're going to add up all of this whole column, this whole frequency. we would get 30 if we added all these numbers right above in that last column. What this is going to be the same as the total number of data entries. So this is going to be the same as total number of data entries, which you'll see that we also are going to denote this with a lowercase n. Okay, so for the next thing here, so that was our frequency distribution, that whole entire little table that we just created. It tells us where all the data entries lie in certain intervals. Okay, so a couple other things here. We have midpoint and relative frequency. So the midpoint of a class, so a midpoint of the interval, is just the average of the lower and upper limit. So what that means is what you do is you add the lower limit plus the upper limit, divide by 2. That's going to give you the midpoint of that class. And the next thing is the relative frequency. So the relative frequency of a class is the percent or the ratio of the data entry that falls in the class. So relative frequency, the way that you find it, is you do the class frequency over the total number of data entries or the sample size. So you can denote that with f over n. So let's take a look at the previous one. So I'm going to fill in what we just filled in on the other one real quick. So here were all of our classes from the previous example here. We said the first one had a frequency of 6, second one had 9, and then 6, 4, 2, 1, 2. So let's calculate the midpoint and the relative frequency for each one of these individual classes. So for the first one, the midpoint for the class of 65 to 104, all we have to do is add the lower limit to the upper limit and then divide it by 2. And we would get a midpoint of 84.5. For the next one, we add lower limit plus upper limit, divide by 2, we would get 124.5. And I'm just going to list off the next ones real quick. And you can see that all of the midpoints for each class, they're all just adding 40 over and over again to get to the next one. And that's because that was the class width for this example. Okay, next let's do the relative frequency. So the relative frequency was f over n. So it was the frequency for the class, which is f, which we have on this table, divided by the sample size or the total number of data entries, which was 30, which I just wrote up here. So for the first class, it's going to be f over n, which is going to be 6 over 30, and we get 0.2. Okay, so what the heck does that mean? What this means, so remember, for converting a decimal to a percent, you move the decimal place over 2 to the right. So what this means is that 20%, so 0.2 represents 20%, 20% of the data falls in this interval, falls in this class. So 20% of the data falls between the data entries 65 and 104. So you can see why the relative frequency is pretty useful. So I'm going to go through and just kind of do the other ones really quickly. So we have 9 over 30 for the next one, which would be 0.3. So that would represent 30%. And I'll just go through and list the other ones off, and you can check those ones on your own. Okay, and these are all of the relative frequencies for each class. So once again, go through and check to make sure that you know how to do this. So that means for, let's say the last class, for the values 305 to 344, we said 2 values for the frequency in our data entries fell between that interval. And the relative frequency tells us that 7% of the data falls in that interval. Okay, so something to take note of is that relative frequency, every single one of those relative frequencies on the right, if we added them up, they should add to a total of 1. Obviously, sometimes you have to round a little bit, or you might round a little bit, so it might not be exactly 1, but technically it should equal 1. So what that means is, I'm going to write this in math notation. It would be the summation of the relative frequency f over n should equal 1. What that represents, a value of 1, represents 100% of the data, which should make sense because that just means that we used all of the data. Okay, so let's do another example here just from the beginning. So let's construct a frequency distribution with 5 classes for the following data set. I'm just going to underline 5 right away. We want to find the midpoint and relative frequency for each class. So here's our data set with all these data entries. So the number of classes is going to be 5 because it's given to us. The range is going to be the max entry minus the min entry. So it looks like these are in order, which is nice. So the maximum entry is, or the minimum is 118, the maximum is 154. So that's going to be max minus min. Subtract those, we get a value of 36, so that's our range. So the class width, now we're going to take that range and chop it up into 5 equal parts. So it's going to be the range over the number of classes. So this is going to be 36 over 5. So when we divide 36 over 5, we're going to get 7.2. But I will make a note again, just so we don't forget, because it is important. We need to round this up. So that means that's going to give us a class width of 8. Okay, so let's fill this in real quick. So the lower limit here, we're going to start at the lower, or the minimum entry, which is 118. And then we're going to keep on adding 8 for the class width until we get 5 different classes. So 118 plus 8 is 126. Plus another 8 is 134. Plus another 8, 142. And plus another 8, 150. So the upper limits are going to be 1 less than the following lower limit. So this one's going to be 125 for the first one because the next lower limit was 126. And then we can just keep on adding 8 if we want, and then we'll be done. So 125 plus 8, 133, plus 8, 141, plus 8, 149, and plus 8, 157. So here are our classes: class 1, class 2, class 3, class 4, and class 5. So let's create this frequency distribution with the midpoint and relative frequency on here. So I'm going to I'll fill in the classes real quick. So here are all the classes from what we just wrote down. So now we would go back up to the data and we would tally for the first class here for 118 to 125. We would count how many data entries fall within that interval. So I'm just going to go up there and just do it for that one again, and then I'll fill in the rest of them. So we go up to the data and we say 118 to 125. So here's 1, here's 2, here's 3, and here's 4. So just remember this is inclusive, so it's including the 118 and the 125. So we have 4. So if you wanted to, you could tally it to maybe make it a little bit easier for yourself. So that's going to be a frequency of 4. So we would go up and do the same thing for the next classes, but I'll fill those in real quick. And we would get those frequencies. So a frequency of 4, 6, 3, 2, and 2. So let's calculate the midpoint. So the midpoint for the first class would be 118 plus 125. So lower limit plus upper limit divided by 2. That would give us 121.5. And I'm just going to fill in these other ones real quick. And we end up getting all of these midpoints for those classes. And lastly, for the relative frequency here, relative frequency is going to be f over n. And our n here is going to be the total number of data entries. So we kind of have two options what we could do to find the total number of data entries. We could just go back to the data set and just count how many we have. Or we could add up the frequencies in the middle column here, and we would get 17. So the relative frequency is going to be f over n. So the first one is going to be, for the first class, 4 over 17. This is going to give us 0.24, which means 24% of the data entries fall within that interval. Next one's going to be 0.35 for 35%, 0.18, 0.12, and 0.12. So the largest relative frequency of 35% means that that is the class that has the most data entries in it. Okay, now for a frequency histogram. So we're going to be using that frequency distribution to help us create a frequency histogram. So all a histogram is going to be a bar graph using that frequency distribution. So the properties of a histogram, the horizontal axis, which we can call the x-axis if we want, it represents the data entries, so it's always going to be quantitative. So horizontal axis are the data entries. The vertical axis is going to be the frequencies. And a couple of properties here for the last two. The adjacent bars must touch each other. So they have to be touching, which means the horizontal axis is going to be a continuous flow of numbers. It's not going to be chopped up. And the last thing here for the fourth one, since it has to be a continuous flow of numbers, previously, let me jump back here to the last example. Let's look at the first two classes, 118 to 125 and 126 to 133. From 125 to 126, there's a jump of 1, right? So that is not a continuous flow of numbers. So if we want to have a continuous flow of numbers here, what we have to do is we have to incorporate something called class boundaries. All this is doing is allowing us to separate these classes without forming that gap of a 1 between each one. And what we're going to be doing is just adding and subtracting 0.5 to each one, which is going to allow us to connect them. So we're going to be subtracting 0.5 from the lower limits, and we're going to be adding 0.5 to the upper limits just to connect the classes, just ensuring that the bars of the histogram do touch each other. So this is what, these are just a random example of what a histogram would look like. So we can see that the bars are touching. The horizontal axis is the data entries, and it's labeled with class boundaries. So we can see how it's 0.5 for each one. And the vertical axis is the frequency for each one of those, individual classes. So let's do an example here using the data from before. So let's create a histogram using the frequency distribution from that first example. So let's find the class boundaries first. So based on that last page, we're going to have to add 0.5 to the upper limit and subtract 0.5 from the lower limit. So instead of using the classes, we're going to use the class boundaries. So subtract 0.5 from the lower limit, it becomes 64.5. And add 0.5 to the upper limit, it becomes 104.5. And then I just have the frequencies for each one of those classes on the right. So for the next one, 105 to 144, subtract 0.5, add 0.5. So now you can see that how they match up here. For the first one, it ends, the upper limit is 104.5. That's where the second one picks back up. It picks it up directly at 104.5, so now they're connected. Okay, and then I'm going to fill in the rest of them. And they're all filled in. And once again, we can see how each upper limit connects exactly with the following lower limit, which is what we wanted, which is the whole point of doing this, using this class boundaries method. So let's create a little rough sketch here of a histogram on this. So we have our horizontal axis is going to be these class boundaries. So what I'm going to do is we need to start at 64.5. So I'm just going to put a little break for accuracy. So it's going to go from 64.5, and then it's going to go to 104.5, So that's the first class. The next one is going to be 104.5 to 144.5. Then 144.5 to 184.5. And then to 224.5 to 64.5, 304.5, and lastly 344.5. Okay, and these are the data entries labeled with class boundaries. And for the vertical axis, this is going to be the frequency. So going back up here, we can see that the largest frequency is going to be a value of 9. So what I'm going to do, just to label this, I'm going to go and say, let's put a max value on this table of 10, and then let's fill in the rest of them. And we get all of those values for the frequency, just 1 to 10. And plop a little 0 down here also. Okay, so what we're going to do is we're going to create a histogram, frequency histogram, using the bars. So for this first one, the frequency was 6. So I'm going to create a bar up to 6. The next one had a frequency of 9. So it goes up to 9. The next one had a frequency of 6. And then it was 4 and 2, 1 and 2. So it's a nice visual. Graphs are just a nice visual for us, so we don't have to sit there and stare at the data entry and decide what's important and where the data lies. It's just we just have to look at it. So we can see that most of the data lies on the bottom half of these classes. Okay, so let's do one more example here for creating a frequency histogram. So the class, this was from the second example. So we have the classes, we have the frequency for each class. Let's figure out the class boundaries. So I encourage you to maybe pause it and just try it on your own just to make sure that you're comfortable doing this. So it's going to be subtract 0.5 to the lower one, add 0.5 to the upper one. So 117.5 and 125.5, 125.5 to 133.5, 133.5 to 141.5, 141.5 to 149.5, and 149.5 to 157.5. So once again, we're going to use these class boundaries to help us label the horizontal axis. So I'm just going to get this set up down here real quick. So here it is all filled in. So we have the frequency for the vertical axis up to 6 because that was the highest frequency up on the frequency distribution. And these are all labeled with the class boundaries. So filling this in here, the first one we had a frequency of 4 for the first class. So make a bar up to 4. The next class had a frequency of 6. So we go up to 6. Next one had a frequency of 3. And then the last two had a frequency of 2. Okay, so this would be the frequency histogram for that data set with 5 different classes here. So obviously we wouldn't always be doing these by hand. There's a lot of different software that'll do it for us, including easy and simple software like Excel and Microsoft Word, but it's good to know how to do these by hand also. Okay, so let's just end with a couple more questions here just to make sure we have a decent understanding of it. So for the first question, what does it mean if a class has a relative frequency of 0.3? So what that means, remember, for relative frequency, this means that 30%, so 0.3 represents 30%, 30% of the data falls within that class. whatever class that is. So relative frequency is a percent, so that means 30% of the data in that class. And let's answer some questions given this frequency histogram. So we have a histogram, and the data is the ages of women visiting the library. And you can see that this one's not labeled with class boundaries, and they're not exactly connecting, but close enough just for an example's sake here. So we have the age of the women for the horizontal axis, frequency for the vertical axis. So let's answer these questions down here. So we want to know for the first one, how many women visit the library between the ages of 40 and 50? So 40 and 50 is going to be right here in the middle. And that's going to be a frequency of 7. So it goes up to a frequency of 7 for that bar. So that means that's going to be 7. 7 women between those ages visit the library for that data set. And last question here, what percentage of women are 70 to 80 that visit the library? So percentage of women 70 to 80, we know that 70 to 80, that 7 women who are 70 to 80 visit the library, because that's what the bar goes up to. For percentage, what this means is relative frequency. So we need to calculate the relative frequency, which is going to equal F over N. So it's the frequency for that class divided by the sample size, which is the total number of data entries. We know the frequency for that class is 7 because we just found it. To find the total number of data entries, what we have to do is find the frequency for each bar, for each different class, and then add them up. So for the first one, 20 to 30 is 1, 30 to 40 is 3, 50 to 60 is 9, 60 to 70 is 12, 80 to 90 is 3, and then 90 to what is most likely 100 right there is 1. So if we added all of those up, this would give us a value of 43. So the relative frequency for that class is 7 over 43, which is 0.16. So that means the percentage of women who are 70 to 80 that visit the library would be 16%. Okay, and that's it for chapter 2.1.